Welcome back, everybody. If you notice, the camera's really close, so I'm going to try to make this easier for you, which means you won't be seeing my pretty face, and I'm sorry for that. I know you're going to miss it, but it should get us closer to here, to the content, which is what I want you to see ultimately. So you're going to see more of my hand. You'll still hear me clearly, but we're going to work this way. So for next week, you're going to have a lesson on Monday, one on Wednesday, one on Friday. And I'll set up a formative for after Wednesday and after Friday. So you can don't do the formative after the first lesson on Monday. Okay, do it on Wednesday. So if you're doing it ahead of time, shame on you. Okay, you shouldn't be doing the formative before the videos anyway, which I pray that you're not. So let's get started. So this is distance learning lesson 8-2-3, day 1. Okay. Where my friend, he saw a negative exponent. Remember that it goes on the bottom of the fraction. Yes. Dad joke, why is Peter Pan always flying? He never lands. Never land? Okay, I know you like that one. Okay, here we go. So 8-2-3, negative exponents. So if you remember earlier in this chapter, we learned how to write large numbers in scientific notation. Astronomers use those large numbers to measure great distances in space, like the Earth to the Sun, Earth to Mars, things like that. But not all scientists work with such a large scale, however. Some scientists use small numbers to describe what they're measuring under a microscope. So instead of going the big way, we've got to go the small way. So in this lesson, we're going to continue our work with exponents. I'll move this up for you. And then you're going to turn your attention to using scientific notation to represent the smaller numbers. So we're going to focus on going the other way. So here we go. So for 872, we have 2 problems that are correct, 4 of them contain errors. So let's look at the first one. So on the first one, we have x to the third, y to the fourth, x to the fourth. If we know what we're doing, what do we have to do when the base is the same? Yep, we have to add the exponents. So 3 plus 4 is 7. The y stays like that. So this one's correct. Okay, let's take a look at the next one. And don't mind the order, this is C. If we're smart, we're setting this up. If we're not sure how to do this, we have 7 times 7 times 8 times 8 times 8, all over 7 times 7 times 7 times 8 times 8. 2 of the 7s cancel each other out, leaving a 7 on the bottom. 2 8s cancel each other out, leaving an 8 on the top. So I have 8 over 7, which is the answer. So this one's correct. Okay, let's go on to the next one. We have, which is D. We have 3 to the 5th times 3 to the 2nd. Same base. What do? Yep, we add. So 5 plus 2 is 7, that's right. Whoa, wait a minute. Why are they multiplying the base? This one's not correct. So it should be 3 to the 7th power. The base stays the same, we just add the exponents. Okay, let's come back over here. So we have 2 to the 3rd power times 2 to the 4th power. Same base, so let's add them. 2 plus 3 is not 12. So this one's not correct. It should be 2 to the 7th power. Okay, here we have 6 times 6 over 6 times 6 times 6 times 6 times 6. We have 2 of the 6's that cancel each other out. So I should have 1 over 6 to the 3rd power. That's not right. The 6 to the 3rd should be on the bottom. So that's one's incorrect. And then lastly, we have z to the 3rd. So z times z over z to the 3rd. Which these all turn into 1s. So this should equal 1, not 0. However, as we're going to learn, and as some of you, if you went ahead, you're going to go, well, wait a minute. Division, we should be subtracting these. Absolutely. So it would be z 3 minus 3 equals z to the 0 power. So this problem does equal z to the 0 power, but z to the 0 power equals 1. Okay, so we had 2 correct and 4 incorrect. Okay, 73, it says rewrite each expression in a simpler form using the patterns you found for rewriting expressions with exponent. If it's reasonable, write out the factored form. If you don't need to write out the factored form, then don't do it. So we have 2 to the third times 2 to the fourth, which equals, good. Everybody should know that one, 2 to the seventh, pretty easy. I have 2 to the eighth over 2 to the fifth. So you gotta think how many cancel each other out, and what are you left with? Yeah, somebody just boarded it out. Thank you, Spaith, for boarding it out. So 2 to the third power. It's about time you started talking in class. Yeah, now that you're not here, you're gonna talk a lot? Mm-hmm. Gosh, I feel for you, Mom and Dad. Sorry, he doesn't do that in class. Okay, for C, we have 5x squared, all to the third power. So we have 3 of those. So we have 5x squared times 5x squared times 5x squared. So ask yourself, how many x squareds do you have? Okay, write it down. And then how many 5s do we have? Now, if we took it, it says write it in a simpler form, that's okay. This would be better if we did 5 times 5 times 5. So having 125x to the 6th power would be even better. And now lastly, we have, and I'm going to move it up a little bit. We have 2 4x's, so we have 4x times 4x. And then we have a 5, we have an x times an x. So we're mashing that all together. So you gotta ask yourself, what are my pieces? I have what, 2 4s? So 4 squared. I have 1, 2, 3, 4 x's. And then I have a 5. So why don't we combine these and leave that one alone? So we have 4 squared is 16 times 5 times x to the 4th power. And this would give us 80x to the 4th power. Okay, so breaking it down does help for some of them. Some of them we don't need to break down. And if you notice here, and we talked about this right before we had this break, is when the 3's on the outside, we multiply. So x squared, 3 times 2 is 6, that's what we ended up. And then 3 to the 5th power, that 3 goes to this piece and it goes to that piece, and that's what we ended up. So you wouldn't have to do that. Okay, this is a big part of negative exponents, so pay attention closely. So Salvador was studying microscopic pond animals in science. He read that amoebas were 0.3 millimeters to 0.6 millimeters in length. Then he saw that euglenas are the smallest, and they're at 8.0 times 10 to the negative 2 millimeters. That's super tiny. But he didn't know how big or small a measurement that was. He wasn't sure what to do with that. So he decided to try to figure out what a negative exponent could mean. So he started doing this, okay? And you can copy this down. So we have 10 to the 3rd power is 1,000. And he divided by 10. He had 10 to the 2nd power is 100. He had 10 to the 1st power is 10. He had 10 to the 0 power, if he's dividing by 10, would be 1. Now the question is what do I do with that? Because notice it's 1,000, we're dividing by 10, dividing by 10, dividing by 10. If I divide by 10 again, this would have to be 1/10. If I do it again, that would have to be 1/100. to the negative third would be 1/1000. So if you notice the pattern, okay, it goes down by dividing by 10, that our negative exponents is actually the number down below, okay? So where you saw 10 to the second power is 100, 10 to the negative second is 1/100. So how are those related? How is this related to this? What would you call those? Thank you, Schmidt. Yes, she said they are inverses. So they're an inverse of each other. So 100 and 1/100. Perfect. So what do negative exponents create? Okay, so what do they create? That's what I'm looking for. So negative exponents create what? Hopefully you came up with they create fractions and or decimals. So if we have a negative exponent, we know that's going to be a tiny number. It's going to be a fraction or a decimal. So anytime you see a negative exponent, think tiny, think small, think microscope, think microscopic, the scientists that way. Okay, so let's take this idea, let's see if you can do this with the next problem, which is 876. And am I sure how to pronounce that? No, but I'm going to call him Ngak. When he was curious about what Salvador was doing and began exploring patterns, so he started doing this. So what I want you to do is do 2 to the 5th, 2 to the 4th, 3rd, 2nd, 1st, 0, -5, -4, -3, -2, -1. So I'm going to give you a moment to write that down and do it. So stop the videotape here, do it, and then turn it back on and you'll see my answers. So I'll pause for a second. Okay, now that you've had a chance, hopefully I'm seeing something that looks like this. That you went 2 times 2 times 2 times 2 times 2 and got 32. 2 times 2 times 2 and you got 16. And then you got 8. And then you got 4. And then to the first you got 2. And then you got 1. And then when you got to here, you got 1/32. And you got 1/16. You got 1/8. And 1/4 and 1/2. Again, inverses of each other. So when we have negative exponents, that should be triggering in your mind fractions, decimals, small numbers. Okay, let's go on to the next one. So in 877, so in those two problems, we had 8-75, 8-76. So this one and this one, Salvador and Ngak, okay? We saw that 10 to the 0 and 2 to the 0 both simplified onto the same value. What is it? Do you think that any number to the 0 power would have the same answer? So hopefully if you were paying attention, 10 to the 0 power and 2 to the 0 power both equal 1. Which tells us that any number to the 0 power is always 1, with one exception, except for 0. 0 to the 0 power is 0, because it's 0. So 0 is not. So anything to the 0 power will always be 1. Okay, so now it's your turn. So what I want you to do is I want you to do 8-88 and 8-89. Do it in your notebooks, write them out completely, show your work. Okay, then you're going to pause the video as you're doing this, and then come back and I'll have the answers up. Also remember, I will have a formative, as I said at the beginning, but the formative is not for you to do till after Wednesday's lesson. So I combined today's, Mondays and Wednesdays, kind of into one big formative. So don't do it till that day. So I'll pause now. Hi, I'm back. And here's your answers. So for 88, you should have gotten 9.25 times 10 to the negative first. B and C were correct. And then D, 8.3 times 10 to the third. And then if you finish that table, okay, that I asked you to, you would have something that's laid out like this. So 10 to the 0 power is a 1, which is 1 over 1, because you had to do it as a decimal and as a fraction. So it should look similar to that. So if I back up, and I know you're going to be mad, hang on. Okay, this is not, I'm sorry, this shouldn't have been, and I apologize because I just caught it while videotaping this, okay, is that we have a typo. So if I go back to here, and go to here, I wanted you to do 89. So on my slides here, ignore this, this should be 89, so my bad. So your table should look similar to that. Hope it was a good success, enjoy, okay? That was the only homework you have, you don't have a formative for today, so relax till Wednesday, then come back and watch the next video. Adios.